Hello, welcome to this live technical discussion series related to earthquake resistant design of industrial structures. So we were receiving many queries from the engineers that we should have discussion on this important code, which is specifically for the industrial structures. Okay. So to start with, I'd like to request you if you can mention in the live chat whether you have used this code in the real projects or not. Okay. Okay, and as usual, we are live on three platforms on YouTube, LinkedIn, as well as on the Facebook. And on Facebook and LinkedIn, probably the stream may get stuck up in between, at certain times. But on the YouTube, the experience will be relatively better. So if you want, you can switch to the YouTube channel, which is mentioned right now, on the bottom of the screen. Okay. Yeah, and if you want to receive the regular updates from our side related to live discussions, online courses, and of course now we are going to plan number of other activities related to, let's say, e-technical discussions, etc. So if you want to receive regular updates from our side, then you can register on the link which is showed on the screen, which is SQVeConsultants.com/register. So after registration, you will receive all information from us as a regular updates as and when the new event is being launched. Okay, and always you can participate in your interesting event or where in events in which you have the interest. Okay. So once again, welcome to this live technical discussion. And today we are going to talk about earthquake resistant design as for industrial structures as per IS 1893 part 4 2015. Okay. Okay, so people have just started joining now. Okay. So very good evening, Chetan. Good evening, Kiran. Yes, good evening, Bharat. Okay, yes, very good evening. So very good evening to all of you, and welcome to this live technical discussion. Okay. So you may share this stream into let's say in the relevant groups or with the interested engineers, so that we can get the wider participation. Okay. And we will have more interesting points for the discussion. In fact, when we announced or when we launched this event in social media, we received more than 300 points. And in fact, before starting this event, we were receiving the points for the discussion. So of course, it's a very vast area. We may not be able to address all the queries which were shared in the registration form, but at least we'll try to address some of them, and then definitely we may plan the discussions in the next sessions as required. Okay, yes, good evening, Ajinkya, good evening, Sumit. So just to start with, can you please mention in the chat box whether you have used this code IS 1893 part 4 2015 for the earthquake resistant design of industrial structures in the real projects? If you have used this project, then please mention yes. If you have not yet used this code for the real project design, then simply mention no. Or let's say you have not gone through this code yet, then you can mention it as no. Okay. Okay, so thanks for your efforts in structural engineering. Okay, so welcome, Soeb. You're attending from Saudi Arabia. Great. Okay. Okay, so let's say within few seconds we will start our discussion related to this code. Okay, Vallabh is telling he has not referred or he has not used this code. I'll request others also to just write down very quickly whether you've used this code in the real projects or not. Simply say yes or no. Because we have received a few comments, a few information in the registration form that they just wanted to get oversight of the code as well. So just now let's reconfirm it maybe from the participants who are online. Okay. So when we talk about IS 1893 Part 4 2015, it was firstly released in 2005, as I remember, and it is specifically designed for the, or rather, it's specifically drafted for the industrial structures. Okay, so now we have started receiving the response from all the participants. Shoaib Nadim has not used it. Nakhom has not used it. Samit has not used it. Okay. Kiran Nikshan has not used it. Thinesh has not used it. Rikhil, no. Okay. Civil Tech, no. Aditya, not used in the real projects. Okay. Not used in the real projects. Okay. Okay, no problem. So earlier, see, there was, if we talk about, let's say, 2002, when IS 1893 was revised in 2002. So at that time, we were having just only one code for the earthquake resisting design. And then it was divided into several parts, as we know. So for the industrial structures, specifically, the code was released around 2005. And actually, speaking, see, there is a lot of difference when we talk about earthquake-resistant design provision between IS 1893 Part 1, 2016, and IS 1893 Part 4, 2015. There are a lot of differences. And one of the major reason is that Part 1, 2016 is generally focusing on the building kind of structures. And when we talk about industrial structures, the industrial structures are highly irregular. And those structures are highly irregular because we have to meet the functional requirements. And because of that, the distribution of the mass and stiffness is highly irregular. And because of this, these structures, or the industrial structures, are highly vulnerable to the seismic events. Okay, so with that concept, or rather, let's say, when we refer Part 1 2016, it was not covering the specific requirements of the industrial structures. So that's why this separate part was developed. So what is done, see, before we get into any discussion, what is done in this code, all different kind of industrial structures. Now, when we talk about industrial structures, there are variety of industrial structures, number of categories, okay, and there are again a lot of diversity. So in this code, all industrial structures are divided in 4 categories: Category 1, Category 2, Category 3, and Category 4. So Category 1 is the structures which are highly important, or in other words, let's say, because of the catastrophic failure of those structures, it can lead to let's say very high hazard to the community. So those kind of structures, like let's say the nuclear reactor plant, for example, so those structures will be defined as a Category 1. Okay. And Category 4 is our building kind of a structures, like let's say administration building, etc. So Category 1 is highly important, and Category 4 is least important with respect to Part 4 2015. That is one thing which is done in this code. And all different clauses are identified with respect to different categories of the structures. The second important part, I think, which we should touch upon right now, is entire code is divided in 2 parts. So part 1 is focusing on the industrial structures, and part 2 is focusing on the stack-like structures. So stack-like structures is, let's say, a chimney, or let's say the vertical vessel, silo. Those kind of structures are considered as a stack-like structures. So for those structures, again, there are separate provisions, yeah, in the code. Okay, so we'll see quickly all these things. So what we'll do right now, I'll just share the code IS 1893 Part 4 2015, and whatever queries we have received through the registration form. So few of the queries we have highlighted in the with reference to the particular clause of the code, and that's what we will quickly discuss one by one. Okay, and I'll be sharing, my experience while using this part for 2015 code, and you're most welcome to share your opinion, let's say, on the specific points, whatever we are talking. And also, please feel free to share as many other discussion points, queries, doubts, or your experiences in the chat box. So we will definitely take those points at the appropriate stage of the discussion. Okay. Okay. And one more thing before we start the discussion, as I understand, or as I remember, I think in 2021, the draft revised code was published for Part 4 2015, and maybe in the near future we may get the completely updated code. So firstly, this code was published in 2005. Then there are two amendments which are issued after first revision in 2015, and then finally again I think draft was already circulated, and then probably we'll receive the revised copy of uh, of this code. Okay, so let's begin our discussion now. Okay, so always we'll be able to interact with the live chat. So whatever points, queries, doubts you have, please feel free to write down into the chat box. Okay, so let me share my screen now. Okay, so now what we see on the screen is IS 1893 Part 4 2015, which is for the industrial structures, including stack-like structures. Okay, so that's what we discussed. That this code is divided in two parts. One is the industrial structures, and another is the stack-like structures. So, of course, we will be focusing our discussion today mostly on the industrial structures, and stack-like structures. We may address it, or we may discuss it separately in the next sessions. Okay. Now, when we talk about industrial structures, see, we can see here, these are all different kinds of industry: process industry, power plants, petroleum, steel, pharmaceutical plants, cement industries, automobile industries, sugar, alcohol industries, glass, ceramic, textile industries. So any industry, whatever we can think of, all industries will definitely come in the purview of this IS 1893 Part 4 2015. Okay. So what I have done right now, based on the queries, whatever we have received through the registration form, so based on that, I have highlighted few of the clauses. So the first query was related to this design basis earthquake. So, so if we compare with Part 1 2016, so in Part 1 2016, the concept of DBE and MCE was removed from the forward. Okay, and this revision was done in 2016. But in this code, the concept of DBE as well as concept of MCE is still there. Okay, and this DBE and MCE, as we all know, it is defined with respect to probability of exceedance of, let's say, 10 percentage in 50 years, corresponding to return period of 475 years. This is the DBE definition of DBE. Okay, and similarly, if we compare the definition of MCE, then here we can see that the probability of exceedance is 2 percentage. Then in 50 years, corresponding to return period of 2500 years. So in MCE, return period is 2500 years, whereas in DBE, the return period is 475 years. As well as also there is a difference in the probability of exceedance, which is here, let's say, 10 percentage, and here it is 2 percentage. Okay, so this was one of the point. Second query we received related to soft story and the weak story. So in the soft story, here we can see that certain definition are given. Now again, we will always try to compare it with the Part 1 2016, because I think most of you are familiar with Part 1. So here some definition is given, which is, let's say, 60 percentage, 70 percentage. Now this enter a definition of soft story and definition of weak story are now updated in the amendment. So after let's say publishing this code in 2015, this both definitions are now updated with respect to sob story and weak story. So you can refer to the amendment, and now in the amendment, this value of, let's say, 16 70 percentage are now removed. Instead, now it is said that if there is a difference in the stiffness, then it will be considered as a sob story, and if there is a difference in a strength, then it will be considered as a weak story. Okay, so the next query what we have received, okay, that was for the vertical earthquake force. So in the para number 6, here it is mentioned that the earthquake generated vertical inertia forces are to be considered in design unless checked and proven. So now this statement is revised in the amendment, and now it is mentioned that the earthquake generated vertical inertia forces are to be considered whenever it is appropriate. And there are several conditions given, like the conditions which are given, let's say, in part 1 2016. Those conditions are also we can refer, same conditions are here. So we can say, in general, that for most of the structure we might have to consider vertical earthquake force. Okay, so that was the query. One more query was related to, okay, here. So the question was that when we are following this part 4 2015 for the design of industrial structures, let's say we are designing RCC structure, then what are the provisions related to a ductile detailing of the structure? So if we are designing, let's say, the reinforced structure, or let's say the pre-stressed concrete members, then the provisions which are given in IS 13920, IS 456 shall be followed. Okay. And if we are designing steel structures, then obviously we have to refer IS 800 for the ductile detailing. So section 12 will be applicable. Okay. So in this code, there are no specific provisions given. Instead of go-to statement is given to the relevant code, which is 13920 and 800. Okay. So this was one of the query. Okay, so I'm going into the sequence, the way clauses are written in the code, and then whatever queries we have written, or rather whatever queries we have got through the registration form. So those queries I'm touching upon quickly. Okay, so if anything is missed out or you have difference of opinion, please feel free to write down as many things as possible in the chat box, and we'll come back to this very shortly. Okay, one query was with respect to the design spectrum. So what is said in part 4 2015, that for all important projects and for all industries dealing with the highly hazardous or toxic chemicals, the evaluation of site specific spectra for DBE and MCE is recommended, because the spectra, as we know, that it also depends upon the type of soil. Okay, and maybe the strata whatever we have, up to, let's say, 15 20 30 meter from the top, let's say, from the ground level, it will actually impact the spectra values. So that's why it is suggested for all important projects and wherever or whatever industries which are dealing with the highly hazardous or toxic chemicals, then evaluation of site specific spectra is recommended. Okay, now how to use this spectra, it is defined here in the next note itself, that these standard specific spectra, whatever, let's say, we define for specific site, that is to be taken as as a criteria for the deformation. Okay, but let's say now if we take these site specific spectra, then now we have two spectra. Okay, so one is our standard spectra which is given in the code, and another is the site specific spectra. So what is mentioned in this note here, just after this 7.1, it says that the standard spectra which is given in the code, that shall be taken as minimum for the strength design of the structure. So we have two spectra, okay, now. So out of that, the standard spectra shall be considered as a minimum for the strength design criteria for the structures. So out of these two spectra, we have to consider standard spectra as a minimum spectra for the strength criteria. However, for the structures with wherever interconnected equipment at one or more levels are there, and where displacement is a criteria, is a governing criteria, so in that case, use of site specific spectra shall be the governing criteria. So whenever the interconnected equipment are there at one or more levels, or where displacement is a governing criteria or a parameter, then use of site specific spectra shall be the governing criteria. Okay. And obviously for all other structures, wherever we have not worked out site specific study, then the standard spectra which is defined in this code, which is mentioned in this code, shall be considered. Okay, that's quite obvious. Okay, so this is what we were talking about, the categorization of the structures. So in this code, all structures, all industrial structures are divided in four categories. So as we just talked about, category one is the structures whose failure can cause conditions that can lead directly or indirectly to extensive loss of life or property. And likewise, if we see category 4 is all other structures. So category 1 is the structures which are, let's say, highly important from the perspective of the loss of life or property, or say uh, the let's say the hazard to the population at a large. And category 4 is the least important structure from that perspective. And then all different structures are then are tabulated in the table number 6. So we'll see in the sequence when we reach to this table number 6. Okay. Okay. This is very important table, and I think this is one of the most important table which shall be referred whenever we are referring to Part 4 2015. It is table number 2, and then it is defining earthquake force estimation, method of analysis and design for various categories of structures. So it identifies that what is the earthquake force estimation method we should use, what is the method of analysis we should use, and what is the method of design we should use for the various categories of the structures. So this table is very important. And just for your information, this table was revised in the amendment number 2 of the code. Okay, so whenever you are referring this code, please take two amendments together, because there are certain important changes made in amendment number 1 and 2. So here on the left hand side, we can see that these are all category of structures, category 1, 2, 3, and 4. Okay. And then in the top part, we can see the methods are identified, which is seismic hazard assessment method. Then what should be the damping? What should be the method of calculating natural time period? What is the method for structural analysis? What is the method for structural design, etc. Okay. And what is the minimum lateral seismic force which we should consider for the structure? So that's why this table is very, very important, right? Now, for the seismic hazard assessment, it says site specific or standard specific seismic hazard assessment as per para number 7, which is applicable to category 1 to 4. This is what we have just discussed, okay, before a few minutes. Damping is, of course, there are so many queries we are receiving on the damping, because in the part 1 it says that the damping is now 5% irrespective of any material of construction, but part 4 says that for RCC it is 5%, and for steel structure it is 2%. And for the other material also, the damping value is given, which is different than even 2% and 5%. So in short, in part 4 2015, the value of damping is changing with respect to material, and we will see in the table, okay, that what impact it is making in the analysis and design with respect to damping. Then method of calculation of natural time period, which is very important. We will again see, we have received number of questions on this, so we will see along with the specific clause also. But here, let's see what is mentioned here. Method of calculating natural time period is the model analysis with all stiffnesses of the lateral as well as vertical load resisting members and masses of the building modeled. Okay, and for preliminary time, the period estimation, see 9.3.2. So we'll refer to this para 9.3.2 and the time period clause which is mentioned in the code. For the structural analysis, it is said, it is very important part, structural analysis. See, for most of the structure, we are performing this linear analysis, right? Linear for the design. Now, what it says, the most important part here in this table, according to me, is this part, which says the non-linear time history analysis for the verification of mechanism. Now, what does it mean? That we will have to carry out, let's say, our conventional process, we have to design the structure considering, let's say, first order elastic analysis. And thereafter, after performing the design, we have to perform this non-linear time history analysis, and then we should verify the collapse mechanism, and then we should see that whether collapse mechanism is favorable or not, or rather it is desired collapse mechanism or not. So, for example, the plastic hinges, let's say, shall form at the initial level in the beams only and not in the columns, just for example. So with respect to that, we have to see the behavior of the structure in the non-linear range, and if the collapse mechanism is not desired, or let's say it's not as we intend, then we have to revise the structure. Okay, maybe with respect to the reinforcement detailing, maybe with respect to sizes of the members, maybe with respect to the structural system. Okay, but this is the most important part for the industrial structures, which I just wanted to highlight. That part 4 is mentioning very clearly that we have to follow, or we have to perform non-linear time history analysis for verification of the collapse mechanism. Now, let's say we have completed the structural analysis, and then the remaining part is structural design. Okay. Now, in the structural design for the RCC, it is very clear that we have to follow limit state design as per IS 456 for the RCC structures. And for steel structures, it is written plastic design as per IS 800 for steel. But in the amendment, amendment number 2, this table has been revised, and this wording or text is revised, and it is said that design as per IS 800. So the word plastic design is removed. So if you know, or if you recall, in IS 800 there is a separate section for the plastic design. So earlier this code was giving direction that we have to use plastic design for the steel structure as per IS 800. But now in the amendment number 2, this plastic design is removed, and it is mentioned that as per IS 800. Okay. And in the last part of the table, there these are the minimum values of the seismic force, okay, with respect to the weight of the structure. Okay, so this table is very, very important. So whenever you're designing industrial structures, I think you must keep this table handy with you. Okay, so the next query was, related to the consideration of seismic forces in a different direction. Now here, in this para number 8.3.2.1.1, what it says that where the plan-wise distribution of mass and stiffness of the structural system is not symmetrical about two lateral x and y directions, then the response due to each component may be combined using the assumptions that when the maximum response from one component occurs, the response from the other two components are 30% of the corresponding maximum. So what it says that if plan-wise distribution of mass and stiffness of the structure system is not symmetrical, so in 99% of cases we'll not have distribution of mass and stiffness symmetrical for the industrial structures, right? Uh, so we will have to consider the seismic forces in two directions simultaneously. Two directions meaning the two principal plan directions. Okay, and when we consider full component in one direction, then in the other direction we need to consider 30% of the other component. And with this, the load combinations are defined here. And we just talked about that the vertical seismic force is required to consider for almost for all kind of structures. Okay, so with this we can say that we will have to consider seismic forces in three directions simultaneously, which is in the two principal plant directions and in the vertical direction. Okay, and whenever we take one component as let's say 100% in one direction, then in the other direction we will consider 30%, 30%. Okay. The next query was, the next query was related to soil structure interaction. So in the soil structure interaction, it is said in the para number 9.1.1 that the soil structure interaction may not be considered in the seismic analysis for structure supported on rock or hard soil or a rock-like material when n is greater than 50 and shear velocity is 760 meters per second. So this para is exactly identical as per part 1 2016. But what it says that whenever structure is supported on the rocky strata, in that case the soil structure interaction may be avoided. So it means that whenever structure is supported on a medium soil or a soft soil, then the soil structure interaction has to be performed. Okay. Now, how to perform soil structure interaction, we can discuss and debate separately, but I just wanted to highlight this point from the code because this was one of the query. Okay, one more query was related to this. Yes, interaction between structure and the equipment, which is para number 9.2. Now, what is this interaction effect between structure and equipment? So the interaction effects between these structures. So structure is considered as a primary system in this para number 9, and equipment is considered as a secondary systems. Okay. So again, there are different requirement is given for, let's say, for the category number 2, 3, and 4. So for category 2, 3, and 4, we have to refer this para number 9.2.1. And for the category number 1, as we discussed earlier, that the category number 1 is are extremely important structures. So for that, para number 9.2.2 has to be referred. So the requirement for consideration of interaction effects between structure and equipment is separated for category 2, 3, 4, and for the category 1. So for category 2, 3, and 4, then it is identified that where equipments are rigidly fastened to the floor. So in that case, the equipment mass shall be taken as lumped mass at the appropriate locations, and no interaction between the structures and equipment shall be considered. So whenever we are supporting any equipment on the structure, so there are two cases, right? So in one of the case, we will mount our equipment rigidly. So equipments will be fastened along with the anchor bolts base plate, and there is a direct connection between the structure and the equipment. That is one type, which is generally which is being used. And the second type, let's say to avoid vibration, or to control the amplitude or during the vibration, we may use base isolation between, let's say, the equipment and the structure. So for that case, the equipment will be considered as a flexibly mounted equipment. So if there is a flexibly mounted equipment on the structure, again the ratio is defined here. So if ratio of, let's say, the flexibly mounted equipment in relation to the rigidly mounted equipment and the structure is lesser, then interaction effect is not required. Or we can go ahead with the decoupled analysis. That's what we are doing normally. Okay. But if this ratio is greater than or equal to 0.25, then the interaction between the isolators, which is a flexible mount for the support of equipment, and the structure shall be considered by suitably modeling the isolators support system while considering the equipment as lumped masses. Now, of course, now how to do all these things in the software, we can discuss it separately. But this is the way it is identified for the category number 2, 3, and 4. And for category number 1, the structure's decoupling criteria are defined in the annexure C. So it is given, with a lot of details. And of course, this we can discuss separately, that how we can consider it in the software. Okay, but this is the way the interaction effect between structure and equipment is identified in Part 4, 2015. Now, this time period estimation is one of the most important points for the earthquake resistant design, right? And as we know that as time period increases, the earthquake forces will go on the lower side. Yeah, and when the time period decreases, structure becomes rigid, earthquake force will be, will be increasing. Now, what is said in this time period estimation in para number 9.3, what it says here, that the time period, if you just read out this is very important para. The time period of different industrial structures would vary considerably depending upon structural configuration, height of the structure, soil conditions, and appropriate percentage of the imposed load. So with these variables, the time period of different industrial structures would vary considerably, and hence any generalized formula for the time period evaluation may not cover all such structures, and it can lead to the erroneous result in certain cases. Hence, no simple guidelines can be given for estimation of time period of industrial structures. And further, it says in the notes that formula given in part 1 for estimation of time period of building, which is para number 7.6, are not applicable for the industrial structures. So why they are not applicable? Because of the reason which is mentioned, in the upper clause, what we just discussed. And second thing, the most important thing, it is said that there is no need to increase the base shear. Of course, it is VB bar here, VB bar by VB for the industrial structures. So with this para, we have received number of queries in the registration form. So whenever we are designing industrial structures, it is written very clearly that there cannot be a generalized formula for the calculation of the time period. And obviously the formula which is given in the part 1, which is that is only for a kind of a building kind of a structures. So those kind of a generalized formula are not applicable to the industrial structures. And now since those formulas are not applicable, it is said that there is no need to scale the earthquake force as we are doing in the part 1 2016. Now with this, it actually brings up a lot of difficulties, a lot of practical difficulties. Now, what happens and what is required when we follow this clause, or when we refer, or when we follow this part for 2015? So the time period will be dependent upon, or rather will be derived exclusively from the analytical model. So, and that's why the modeling of the mass and the modeling of the entire stiffness of the structure has to be reasonably accurate, so that the time period value what we get out of the analytical model is reasonably correct, so that the earthquake force estimation is also reasonably in the required range. So there were instances when we are designing number of industrial structures. This is what we felt, that sometimes maybe because of inappropriate modeling, we get a time period too higher or too much on the higher side, and because of that the earthquake force what we get for the structure is it's actually very less. So there were few instances where we applied our own scale factor whenever we felt that the earthquake force is too low. So depending upon the height and importance of the structure, and based on our own internal database, we try to calibrate. So of course, whatever earthquake force we get out of this code, we consider it as a minimum value, and over and above, if we fail, we put our scaling factor. But in this code, in part 4 2015, it is scaling of earthquake force is not mentioned, okay, which is there in part 1 2016. Okay. Now second thing, in the similar area of time period, as we just talked earlier during discussion for the table number 2, it was said that the para number 9.3.2 can be referred for preliminary design. The time period can be established based on its static deflection under mass proportional loading in each of the three principal direction, and based on that we can estimate the time period with this simple formula. Okay, so this is one of the way. Damping, there are a number of queries and we discussed. Okay, so the damping factor to be used in determining the spectral acceleration coefficient SA by G depends upon the material and type of construction of the structure and the strain level, right? And the recommended damping factors are given in the table number 5. So let's see if we directly, okay, let's go to the table number 5. So when we refer table number 5 for the damping ratio, now here we can see that there are different materials given, right? Aluminum, steel, RCC, pre-stressed concrete, we can see. So for steel, it is 2%, and for reinforced concrete, it is 5%. And again, here damping are specified for the let's say DBE and MC, which is for the design basis earthquake, and for MCE earthquake. So for MC earthquake, the damping value which is suggested for steel structure, it is 4%, and for RCC structure, it is 7%. Okay. Okay, there are a number of queries related to dynamic analysis as well. So the dynamic analysis shall be performed for the 3 orthogonal components. So obviously 2 horizontal and 1 vertical of earthquake motion, resulting in evaluation of earthquake loads, which is in X, Y, and Z direction. Now here it says the influence of P delta effect as well as torsion shall also be included in the analysis. So we'll see this, what is mentioned in para number 10.3 for the P delta effect. So before that, again, the analysis which is mentioned here, let's say, is divided in two categories. So one is the detailed analysis and another is the simplified analysis. Okay, and this detailed analysis shall be carried out for structures of category 1 in all seismic zones, then structures of category 2 in seismic zones 3, 4 and 5, and then structures of category 3 in seismic zone 4 and 5. And simplified analysis may be carried out whenever structures are of, let's say, category 2, which is in seismic zone number 2, and structures of category 3, which is in seismic zone number 2, etc. And for all structures which are in the category 4 in all seismic zones, we can go ahead with the simplified analysis. So two types of analysis mentioned here. One is the detailed analysis, another is the simplified analysis. And then this requirement is again differentiated with respect to the category of the structure and the seismic zones. Okay. Okay, here. So what is detailed analysis, right? That is a question. What is the detailed analysis? So the detailed analysis is the dynamic analysis, may be performed either by a time history analysis method or by response spectrum analysis method. Okay, and already we talked about this nonlinear time history analysis method or which is required for the verification of the collapse mechanism. Okay, so this is again elaborated in a 2-3 lines in the para number 10.1.1. That's a detailed analysis. And response spectrum analysis method concept is similar as with respect to part 1, 2016. Okay. And what is the simplified analysis? So the simplified analysis shall be carried out by applying equivalent static seismic forces along each of the 3 principal directions, one at a time, and the horizontal seismic coefficient H shall be determined in accordance with 7.3.1, etc. So it is divided in 2 kinds of analysis, a detailed analysis and the simplified analysis, depending upon the category of the structure and the seismic zone. Okay, we received few queries related to P delta effect. So as per this code, the P delta effect has to be considered for all structures. So structures in all categories and in all zones shall be analyzed to take into account the influence of P delta effect. Now, how to consider this P delta effect in the software? Again, it's a different part of a discussion, and there are a number of gray areas according to me in a particular software, or let's say software to software, those area also varies. But there are certain points which we need to discuss and elaborate when we talk about P delta effects. But what is mentioned in this code, that P delta effect shall be considered for all structures in all categories and in all zones. So for all RCC, all steel structures, the P delta effect is must as per this code. Okay. And the provisions for the torsion is identified in this para, that how the torsion has to be considered. Okay. And here I'll just highlight one more point here. What it says that the RCC flooring systems in a steel structures shall be considered flexible unless properly designed floor bracings are provided. So if we have provided RCC flooring system in steel structures, then And if you do not provide a properly designed floor bracings, then that system will be considered as a flexible system. This is what is written here. Okay. Deformation. Okay. Yeah. Okay, then there were a couple of queries related to separation between the adjacent units. So when we compare this para with respect to part 1 2016, it is almost similar, but there is a only difference here in the last para. What it says that when floor levels of two adjacent units or structures are at the same elevation levels, then separation distance shall be r by 2 times the absolute sum of the maximum calculated story displacement plus 25 mm. Okay. So whenever there are two buildings, two adjacent buildings, and if the floor levels are at the same level, so in that case the provisions are different. So it is little bit relaxed, we can say, because here it is actually r is divided by 2, whereas in the first part of this para we are multiplying the absolute sum of displacement with the response reduction factor, that means with r. Okay. Yeah, so this is the difference between two codes. Okay, and related to these this foundations, what is said that whenever the spread footings, or let's say the pile cap, which are, let's say, if they are not supported on a rocky strata, or let's say how it is mentioned here, that the stability of foundations vulnerable to significant differential settlement or overturning due to ground shaking shall be checked for all these seismic zones. Okay, so individual spread footings or pile caps shall be interconnected with ties, except when individual spread footings are directly supported on rock. So whenever they are directly supported on rock, the spread footings, if they are directly supported on rock, then tie beams are not required. Otherwise, tie beams are recommended, or rather they are mentioned for all different cases except rock. Okay. And the provision is also mentioned here that how that tie beam shall be designed. Okay. Okay, so this is the table number 6, which is defining category of all industrial structures. And here we can see that it is attempted to cover all possible industrial structures here. But again, it happens whenever we are referring this code, it is possible that we may not get exactly, the structure name, what we are analyzing is not listed here. So in that case, we might have to find out the similar structure probably, and then we might have to use the engineering judgment. But according to me, the most of these structures are attempted to cover in this category. And here we can see that the name of the structure is mentioned. Let's say, for example, this process building, and then category of the structure is mentioned, which is, let's say, category number 1. And similarly, here we can see just this example, air water pump house. So for that, the category number is 4. Okay, so likewise, all name structures are mentioned here, and the category is also mentioned. Okay, and after that, all the section starts for the stack-like structures. So these stack-like structures we will consider separately in the next discussion. Okay, but I'll just touch upon a couple of points here based on the queries we have received. So one of the query was related to this damping. So here we can see that the damping for the steel structure is 5% here. So now this table is actually revised in the amendment number 1. I think amendment number 1 or 2. I am not very sure, but it is revised in the amendment. And for the steel structure now, this value is mentioned as 0.02 in the amendment of this code. Okay. And here we can see for calculation of the time period for the stack-like structures. Again, the different formulas are given here, because for stack-like structures, the structure is substantially different as compared to the, let's say, conventional industrial structures. Okay, so the time period formula will also change. The calculation will also change. So it is defined separately in this section. The importance factors are also defined here for all different structures. Okay, and we'll discuss this separately in the next session. So when we move towards the end part of the document, there is annexure A, and in the annexure A we can see the multiplying factors for the obtaining values for the zone factor Z for the other damping ratios. So here we can see that the damping ratio, if my damping ratio is 5, then in that case the multiplication factor is 1. Okay. So for RCC, my damping factor is 5%, so multiplication factor is 1. And for steel, my damping value is 2% as per part 4 2015. And with that, the multiplication factor is 1.4. Okay. So whatever spectra value we get, that value shall be multiplied by 1.4 as per this table. And this is the standard design spectra, which is defined in the code. Okay, and here it is said that this is to be used for the first mode, and this is to be used for the higher mode. So here, what does it mean? That for the first mode, we have to use value as 2.5. Okay. And if we are performing, let's say, response spectrum analysis, and then we are combining the modes, and in that case, in the higher modes, it's quite possible that we may get a time period value very, very close or very less. And if it falls in this range, which is shown as a dotted line, then in that case, let's say between 0 to, let's say, 0.23, then in that case, we can refer the values as per this dotted line. Okay. Only in the case of the higher mode. For the first mode, it has to be 2.5. And finally, this is the annexure C. This annexure C also we will discuss separately, maybe in one of the sessions, because it requires detailed discussions. And how to do, first of all, we'll try to understand these, and then how to apply it in the software also, we will discuss it. Okay. Okay, so this was a quick view about IS 1893 part 4 2015. Okay. So we have just tried to touch upon the discussion points, whatever we have just received through the registration form. Okay, now let's take up a few points. Now we are opening this discussion for the live chat, for the open discussion. Okay, so now you can start populating as many queries you have, and let's start discussing this. And also, please feel free to share your own experience related to certain provisions of the code, and that we will take up here. Okay, so first is Shirang Agrawal is telling table 2 says minimum percentage EH, whereas for site specific spectrum, importance factor and R should be taken as 1, which means that you need to consider the corresponding force, which force we shall be following. So of course it is said that the design spectra or the standard spectra is the minimum value for the strength criteria. So whenever the value is higher in the site specific spectra, then definitely we'll have to follow the values as per the site specific spectra. Okay. Okay, Abhishek saying is asking, can we use section 18.3 of NBC for steel structures to avoid section 12? Can we use? Okay, see that there is one update I think we discussed in one of the session that when this NBC was revised in 2016, so at that time entire code IS 800 2007 is reproduced. Now it is reproduced along with the amendments, whatever amendments which were published after IS 800 2007. So those amendments were added, and secondly, the few changes are made into the document. So with that, we can say that IS 800 2007 is already superseded, because NBC 2016 is having the latest provisions with respect to steel design, or with respect to let's say, or IS 800 2007. So of course we can follow the steel structure specifications which are given in NBC document, according to me. Okay. For Ganesh is telling, for industrial structures, can we consider R is equal to 3, use OMF in zone 5, avoid section 12 of IS 800? No, it's not permitted, because see, it is written now. If you refer section 12 of IS 800, it says that OMF itself is not permitted in zone 5. Okay. And in fact, when we just received the draft code for the ductile detailing for the steel structures, so in that draft code, it was mentioned that for all structures, maybe in seismic zone 4 and 5, shall be provided with the eccentrically braced frame. Even SMF was also not allowed. So of course, that is a different topic for a discussion, but regarding OMF, according to me, it cannot be considered. Okay. Okay. Okay, so please feel free to mention your discussion points, and we will take it up sequentially. So whenever we are designing the structures with respect to IS, okay, well, good evening, Dr. Rajesha. Whenever we are designing the structures with respect to IS 1893 Part 4, 2015. So at that time, the consideration of time period is extremely important, right? Because there is no scaling factor which is there as it is mentioned in the IS 1893 Part 1, 2016. Okay. So that's why our modeling has to be perfect, and the proper dynamic analysis should be carried out, and we have to see that all different steps, whatever we have followed for the dynamic analysis, are correct. And of course, there will be number of trials and errors which will be required. So there were a few cases, as I was just talking during the time period, where we were getting substantially higher time period. And when we look at the mode shape, we can see that it is just only a local mode shape which is participating in the structure, or rather it's a local mass, because let's say we modeled all small operating stages also in the structure. So the small operating stage was participating in the first mode, and because of that, the time period was extremely higher, and because of that, the seismic force on the structure got reduced. So of course, the appropriate dynamic analysis is must for all industrial structures, because there is no benchmark given in the code as compared to part 1 2016. Okay, Indrajit is asking, sir, mostly PB consultants are using part 1 for designing warehouses. When shall we have to consider IS 1893 part 4? According to me, for all industrial structures, IS 1893 part 4 shall be followed. And as we were just talking in the beginning, if we see uh, the document, initial part of the document of IS 1893 part 4 2015, it gives very clear uh, definition of the industrial structures, like for which industry we have to consider the industrial structures. So now when you say the warehouses, now actually we have to see that what is the process which is going to occur within that structure, and what are the different units also, different kinds of machines, if there are any. So if it falls as per in the table which is given in the initial part of, let's say, part 4 2015, then it must be designed as per IS 1893 part 4, because part 1 was designed, or rather it is actually talking in a general sense about the earthquake resistant design. It is and then let's say we can say that up to para number 6 in IS 1893 part 1 2016, it is talking for the general clauses, and then the next para, which is, let's say, from para number 7 onwards, are only for the building kinds of structure. But when we talk about the industrial structures, then definitely those para number 7 onwards will not be applicable. Okay, and that's why we must follow IS 1893 part 4 for all industrial structure. Okay, Lali Wala is telling, can you give one example of irregular plan geometry steel structure design example? Okay, see, whenever we talk about industrial structure, how the irregularity will come in picture. So we can say, let's say the geometry wise, my entire structure is, let's say, almost symmetrical from the perspective of the geometry. But the distribution of mass will be highly irregular. For example, let's say at one of the floor, I have 100 ton of equipment which is sitting. On the next floor, it is, let's say, only 10-15 metric ton of equipment. And again, it is off-centered or sitting at a different location. So with this, we can see, all different equipments are sitting at a different position, different levels. So with that, even if geometry wise structure is regular, but it will become irregular with respect to the mass. Okay. Okay. Okay, so this is a brief about IS 1893 part 4 2015, and still there were a number of queries what we received through the registration form related to the software application part, so that we can deal or we can discuss separately, like, let's say, P delta analysis, interaction effects between equipment and structure, then performing appropriate dynamic analysis, etc. Okay. Okay, Laliwala is telling, sir, I am seeing irregular geometry in plans. Yeah, see, I'm not getting your exact question. If you can just elaborate it a little bit. Okay, you are junior engineer in a PEB company. No problem. It's okay. Yeah. So see, the irregularity is with respect to mass, what we just discussed. Now, similarly, the irregularity also would be with respect to unequal distribution of the stiffness. So even if, let's say, my geometry is irregular, but if I am putting the stiffness almost symmetrical, building will become regular. So So it's not about only about geometry. It's we can say, we can talk in this way, that it is about distribution of mass and stiffness in the entire structure. Okay. Trapezoidal shape. Okay, let's do one thing. You can share a few diagram sketches to me separately, and then we can discuss. Okay, with respect to the irregular geometry. Okay. Okay, and there is just small announcement that now we will be starting online workshop for the steel connection design from 3rd October 22. So the link is mentioned on the screen. If we are interested, you can just visit this link, and then you'll get more information. Because steel connection design is again one of the gray area in the industry. So that's what we are going to focus. And we have defined it as a kind of a workshop, because we all will try to explore it together, and we'll try to formulate something out of the number of exercises what we'll be carrying out during the workshop. So okay, so if you're interested, you can just visit this link. Okay. Okay. Okay, Laliwala is telling how can he share. Okay, okay, you can connect with me, on any platform and any social media, and then you can share it with me. Or let's say you can drop your contact details here in this live chat, and then we will contact you. Okay, I'll send across my details. Okay, Mohammed is telling how to calculate and apply seismic forces on a steel gable frame. So of course, now let's say for most of these structures, now we have to follow a response spectrum method. Now for the response spectrum method also, separate discussions are required, because there are a number of areas what we need to see. And there are, I'll tell you, there are a number of blunders I have seen because of the improper application of the response spectrum method. But in your coming back to your question, generally it will be done automatically into the software. Okay. So and for most of the structure, we will have to follow the response spectrum method. Now again, in a different software, there are different pointers which we should understand step by step approach from their manual, as well as from the worked out examples, for the proper application of the seismic force based on the response spectrum analysis. Okay. Okay, so still you can mention your queries, questions related to the industrial structures. Okay, and once this video is completed, again it will be published on in the social media. So again, you can mention your additional queries. Based on that, we will decide the content for the second part. Okay, as we could see in the initial part, that there are a number of participants who have not gone through this part 4. Okay, so I've just tried to touch upon different clauses, and again, whatever queries we have received through the registration form, so that also we have discussed with respect to certain clauses. Okay. Okay, so I hope that those you that discussion would be helpful to you if you are going to use this part for 2015, or let's say if you are using this code. Okay. Okay, so with this, now we are coming towards closer of this session. Okay, so just within a couple of minutes we will close this session. Okay, so if there are any other points or anything you want to share, please share through the live chat before we close it. And now we have an aggressive plan. Of course, till now we were conducting sessions on a monthly basis, but now we want to increase the frequency of the sessions, because we have received so many other points or so many other areas for such kind of a discussion. So that's what we are planning. So please keep following us on a different platform, and and also please keep on suggesting the areas where you would like to have this kind of a discussion. So generally we are targeting the areas wherein generally industry is facing practical difficulties. Okay. Okay, so thank you all, and that's all. Now we are coming towards closer of this session. So now we are closing this session. Okay, so I am now signing off. Goodbye, and we'll meet you. We'll meet very soon in the next session. Okay, bye from my side.